Welcome to my channel. In this video, I'm gonna explain about the topic real zeros of polynomial functions. This is the continuation of the previous video. Let's start our video. Here the first is the rational zero theorem. Let's start. What is rational zero theorem? Here there is one polynomial that is in the form that is f of x equals an x power n plus n minus 1 x power n minus 1 plus n minus 2 x power n minus 2 plus etc. plus a on x plus a naught is a polynomial function with integral coefficients. Here the coefficient of an minus 1, an minus 2, etc. a naught, right? Here we consider only two coefficients, that is an and a naught, that is not equals to 0. And p by q, we know that what is the format of the rational number. It's a format in the format p by q, right? That q is not equal to 0. Here this p by q is a rational zeros of f of x. Then p is a factor. Here the p is a factor of the constant term and q is a factor of the leading coefficient an. That means here the p, if we consider the p as a factor of the constant term. If there is a quadratic equation, in that we consider the constant term a naught, that means a constant value as p, and the leading coefficient as q. Okay, I hope you understand this. Then in leading coefficient means it's in a quadratic polynomial, the coefficient of x square is a leading coefficient, right? That is we consider as q. We can write p by q. Let's see one example related to this. Here is one example. Here we find all the possible rational zeros of p of x. This is a polynomial. We need to identify the possible rational zeros. In the question, they didn't ask what is the factor of this. They only ask what is the zeros, possible rational zeros. Only they have asked in this question. We just find what are the possible rational zeros of this polynomial. Here just we use the previous theorem, that is rational theorem. By using that, let's identify. Here p is what? P is I explained in the previous slide, the coefficient, the constant term, right? Here the p is 6 and q is the leading coefficient, that is 2, right? Then we need to identify the factors of 6. What are the factors of 6? That means 1, 2, 3, 6. These are the factors of 6 and 2. This is the prime number, so it has only two factors, that is 1, 2. Right here the possible rational zeros are 1 by 1, that is plus or minus 1. It may be possible. It's plus 1 or minus 1. Then 2 by 1, that is equal to plus or minus 2. It may be possible. Then 3 by 1, that is 3. 6 by 1, that is 6. Then 1 by 2, that is plus or minus 1 by 2. Then 2 by 2, that means equal to 1. We get that. That is 1 by 1 equal to 1. We get it. That is 2 by 2 is equal to 1. We already got this plus or minus 1. Then 3 by 2 and 6 by 2 means that is 3, right? That is plus or minus 3. These are the possible rational zeros. Okay, I hope you all understand this example. Let's say another one example. Let's check. Here they ask the question finding all the real and imaginary zeros of this polynomial, the same polynomial. We already find out the possible zeros. These are the possible zeros. These are the possible zeros. We need to identify what are the real zeros or imaginary zeros of this polynomial. By using synthetic method, we can check what are the possible zeros. Okay, that means first, that is 1 by 2. Here is 1 by 2. We write the coefficient of this polynomial. You write 2, then 2 into 1 by 2 means that is 1. 3 minus 1, that is minus 2. 1 by 2 into minus 2, that is equal to minus 1. We put here. If we add this, we get minus 12. minus 12, 1 by 2 into minus 12 means it's minus 6, that is 0, right? We get the answer. Here x minus 1 by 2. This is a factor. Then another this is we need to write this. That is we write 2x square minus 2x minus 12. Okay, here x minus 12, right? Here x minus 1 by 2. Here this is 2x square minus 2x. I take 2 as common here. That means 2 as common. Then I write x square minus x minus 12 equals, minus 6 equals 0. Then I wanna cancel this 2. So I take LCM of 2, that is 2x minus 1, that is 2 into this x square minus x minus 6 equals 0. I cut 2. Here get 2x minus 1, again this x square minus x minus 6, that is equal to 0. Okay, then I need to find the factor of this x square minus x minus 6 equal to 0. What are the factors we get here? X square minus 3x plus 2x minus 6 equals 0. Then I take x as common here, that means I get x minus 3, and here I take plus 2 as common, I get x minus 3 equals 0. The factor is x minus 3, x plus 2, that is equal 0. I get the value x equal to 1 by 2, 3 minus 2. These are the real zeros of the polynomials. I hope you all understand this very well. I just recall once again. Rational theorem means if they give a polynomial, here we consider p as a constant coefficient and a q as the leading coefficient. Okay, the rational number is in the format p by q. Here is one example, that is leads a rational theorem, and another one how to find all the real and imaginary zeros of this polynomial. For that we use a synthetic method. I hope you all understand this. Thank you.